Do some logarithms. Properties of logarithms. So we're going to take some logarithms, and we talked about those back before spring break, and as a function. We're going to work with them more as expressions and rewriting them using some properties that they have, and then simplifying or expanding or condensing. So there's several different things. It's a lot of repeat from Algebra 2. We did that, I know, in my Algebra 2 classes. I know pretty much, yeah, Coach Mack for Algebra 2, I know you did it too. So it's a lot of the same stuff. So first property, there's no real rule about how you number the properties. I'm just numbering this one property number 1. It doesn't matter. Doesn't matter what base here. I'm going to use log base A for all of these. It doesn't matter what the base is. The property still holds no matter if it's base 2 or if it's natural log, which is log base E, or base 10. It doesn't matter. The property holds for that. So here we have a log of 1. And what you got to think is, okay, A to the 0 power is 1. So that's why that property holds. And anytime you have any log of 1, it equals 0. So that would be a simplification type property that you could use. Second property would be another simplification type property, is if you have the log base A of whatever the base is, then it's equivalent to 1. So basically this log and that one cancel each other out and make 1. Really, really simple idea. In the same vein of that, an exponential property with logs, A as the base with log base A of something else. These two, this log and this base A cancel each other out, just like this log and this base A cancel each other out, so that it equals M, or whatever's in here, what it equals. And we'll see these as we do some examples, actually using them. Not likely you'll find a problem where you'll use every single property that we have. I mean, it's just not, that would be a very large problem. Then log base A of A to the R. So just same base with an exponent. It's going to be R, whatever that exponent is. So this is related to this property here. They're related. All three of these are very much related to one another as far as that goes. Just go here to the right. These are the next few properties are expansion and condensing properties. That logarithms are really just what? What did we say that they were? Exponents, okay? So with exponents, what's the rule that you use when you multiply things that have the same base? What do you do with the exponents? You add them. So in a log, remember logs are just exponents. If it's multiplication in here, then it just turns into addition. So that you could rewrite it log base A of M plus log base A of N. That you can expand that, and it works the other direction too. If you had 2 logs here, you could condense it into one that's a multiplication problem. So that's going to help us, especially when we go to solve equations next section. So this section is more about working with the properties. Section 6.6 is more about solving equations, and you got to apply some of the properties to be able to solve them. Okay, so that's where that's coming in. So if multiplication turns into addition, what would turn into subtraction? Division, yeah. So no matter what log base we've got, if we've got something divided by something else, it just turns into a subtraction problem. Top minus bottom. Here's a nice property that looks very similar to 4, except for it doesn't have the same base here. It's a different base. What's the rule with exponents and parentheses? Like if there's exponents on the outside of the parentheses, you multiply. So this is kind of like what that is, that you can take that exponent and drop it down to the front so that's r times log base a of m. And that can help us quite a bit when we go to solve. Can take an exponent out of that and make it a multiplication problem, makes it a lot easier. Multiplication. That's the property that this, whatever this exponent is, can drop down to the front and make it multiplication times the log. That's a 3. It pulls it down to the front 3 times log whatever that we can use. That's handy later on. The natural log works the same way. Here's a small example of how we could use that. Maybe this is the 8th property here that your book tries to kind of squeeze in here. Yeah, it's neat, but it really doesn't. You don't use it very often. You got a different base on each side. One's base A, the other side's base E, so those don't really work out great. But through the use of some nice property stuff here, this goes up there. It's the reverse of this particular property. This could be a natural log of a to the x. So that's just showing. I'm showing you why this property exists. And then these two, E and natural log. Natural log is what? It's log base what? E. So they cancel each other out from this property. The same base and the base right here. They cancel each other out. Though that cancels out, so that's how that property works. Like I said, this property here, it's written in black. That property right there, not used a ton, but how it works is probably used more than the actual property itself. Like the fact that you could do that and cancel it out so that they're equal on each side. That's going to be more important maybe next section when we start solving some equations than it is as a property itself. So, all right. So what we're going to do is take those properties and do some expanding, do some condensing, and that's it. So not a strenuous lesson to start out with after spring break. So let's do some expansion first. Expansion.
Sparks and Kelly LeCompte report to office.
I think your book says write these as a sum or difference. I kind of guess I'm stuck in the way that I learned it. We called it expansion back when I was a kid. So that's what I've always called it. And maybe that's what my teachers have always called it. So that's why I call it that. So let's just start with something really easy. Log base 2 of xy. We've got a single log, and what we want to do is break it apart using the log properties. What's going on inside of that log? Multiplication, so that means it's going to turn into addition. So yeah, you guys, this should be, an easy section. Should get us, a pretty easy grade on a quiz here because this is stuff you did in Algebra 2, no doubt. You did this in Algebra 2, or your teacher presented it to you. Whether you did it or not, maybe up to you. But let's step it up a little bit since we're semi-experienced in this. Log base 3 of 3 x squared y. So there's 3 things inside of there. So that means it's going to turn into what? But what does that become, though? Log base 3 of 3. So splitting it apart, there's 3 things. So that's really log base 3 of 3 plus log base 3 of x squared plus log base 3 of y. I'm with you there. What does this turn into? And becomes what? 1. So it doesn't go away. It becomes 1. And then what can this one do? It could be the 2 out front. That's the property we want to employ there. And then there's nothing else we could do to log base 3 of y. So this would be the completely expanded form of that. When they ask you to write it as a sum or difference, that means go as far as you can with any of them, any of the pieces out of that. Let's do log base a of x square root of x squared plus 1. Again, I'm using log base a. It doesn't matter what log base it is. These properties are going to hold for that. So again, it's what kind of problem inside. It's multiplication with the x and then the square root of the stuff. Okay. Okay. Square root of x squared plus 1. Because all of that is underneath the square root. Okay. Now, here's where most people stop and they're wrong. Because this could be broken down one more step. Only one more step. What do we know about the square root? It's the same as to the 1/2 power. That this is x squared plus 1 to the 1/2. So what can that 1/2 do? Drop to the front, just like up here with the x squared. So that ends up being log base a of x plus 1/2 log base a of x squared plus 1. Now, can you split apart an addition in here? We don't have a property that splits addition. We have properties that split multiplication and split division. We don't have a property that splits addition there. Okay, so that would be the expanded form for example C. If it's on the bottom, it would be be a negative. Let's go to that. Let's do log base 4 x squared y over w. So what's the big glaring thing that's going on here? It's division first. There it looks like a big fraction. That's the part that glares at us and says, we don't like you. So let's change it. So it turns to subtraction, yeah. Top minus bottom. Okay. That should be double, yeah. Thank you. All right. And then can we expand any of those? The first one is multiplication inside, so we can make it addition. And then can we go any further with any of those? Yeah, and I'm okay with you doing more than one step at once. You should. I mean, honestly, I normally would not take an extra step just to do this. I would have done it the first time. And there's the expanded form. B. kind of get into a few that are maybe a little more challenging as far as details involved. Log base A of the square root of xy. You could. I'm not necessarily sure that that's the easiest way to do it. You could do that, yeah. So I like what Jared is saying here. We take 1/2 power out in the front and then have log base A of xy left. And then we can take that part and make it addition, yeah. So it doesn't necessarily make a difference. Why did I put those in parentheses though? Yeah, it's 1/2 to both of them. So this is an acceptable answer. Also, if you had the 1/2 distributed, which you would have arrived at if you had to split this apart into square root of x, log base A is square root of x times and then square root of y, and split it apart, you would have ended up at the same place. It's equivalent answers out of that. So that's acceptable, or distributing the 1/2 would have also been acceptable to that. Some more space for this next one here. A little bit more involved. Log base 5. You put big parentheses there. Oh no. X squared. Log base 5 of x squared over x minus 1 to the 3rd power. Let's try to go in one step if we can. Okay, it's going to be subtraction. What's going to be on the front? 2. All right, so the top part is going to be 2 log base 5 of x minus, no, not 1/3. It's not a cubed root. And then inside of that be x minus 1. That would be a place, right? You said the parentheses don't matter. This would be a place it does. So that you can see that it's, it's not just log base 5 of x, it's log base 5 of x minus 1. And then that would be it, yeah. And that's handy. Last one of the expansion problems. Let's make it a doozy. Natural log of the square root of x squared plus 1 over x cubed, parentheses, x plus 1 to the 4th. That's a fun one. When you multiply those together on the log? They are it is multiplication on the bottom, but definitely don't want to multiply it out. That just complicates it even further. Okay, so that's what our job is, to expand it, break it apart. So what's the, it's a fraction, so it's going to turn into what? Subtraction at some point here. So what's the front part of the subtraction, the first term? It'd be 1/2 natural log of x squared plus 1. This is inside. That squared right there doesn't matter. So because it's inside of the log, the stuff. The 1/2 power is what from the square root. Okay, and then that's the top part. Minus okay. There's one thing missing. Where? So you're saying right here, Hannah? That I'm gonna use a bracket just because it emphasizes a little bit more. Why is that correct? Because that's the whole bottom. Yeah, we're subtracting the entire denominator. That's exactly right. That's important. What would also be an equivalent solution to that? Without the bracket in there. No. What could we change if we took the bracket out? What do you mean?
We could add it.
No, you can't add.
We flip the signs, wouldn't you?
Well, so this stays negative, and then this would also become a minus. If you distribute the minus sign to both things inside of the bracket, that's an equivalent solution to that. The expansion, we're subtracting all of this bottom part, so we can do it with a minus in front and then a bracket of everything inside of there, or we could distribute the minus sign to both, everything that's inside of there, and it's okay. Either of those would be acceptable as far as that goes. All right. So there's some expansion. Expansion is maybe not as useful in solving as condensing is going to be, but it is necessary in some cases. Just enough cases we need to be able to do it. It also helps us learn the properties so that we can go the other direction and condense. It's kind of like when you learn to do like FOIL method and multiply out polynomials. The next thing we did was factoring, take them back apart. So this is kind of the idea here, is that you expanded them, now that's condensed them. Because if you can condense, you can get it down to a single log. So write a single logarithm. And if you're trying to solve something, if you can get it down to one term instead of 5, gosh, that's a lot better than having 5 things to work with. Because one thing is easier to undo than 5 of them are. Okay, so what are we on? H. So we're going to start with something that's expanded already. Log base A of 6 plus 3 log base A of x. So we see addition in the middle, so that means it's going to be what kind of stuff inside? Multiplication. So it's going to be 6 times what? X to the third. Good job. Log base A, 6x to the third. You don't have to have the parentheses there, but I just do that out of habit, I guess. One third natural log of x minus natural log of x squared minus 1. Let's condense that down into 1. We see a minus sign in there, so that tells us it's going to turn into division. What's on top? Cubed root of x over just x squared minus 1. I'll put it all in parentheses there. Why is that the cubed root? 1/3 power, same thing as cubed root. All right. Log base 5 of x plus log base 5 of 9 plus log base 5 of x squared plus 1 minus log base 5 of x minus 3 minus log base 5 of y. We're going to condense that one down into 1. It may take more than one step on this one. I don't know. You guys may be better at it than I am. Maybe you can do it one step. Yeah, I can probably do this. You could. So what all's going on in this problem? Multiplication And there's some subtraction there, so there's also some division. Okay, so what all is getting multiplied together and going to be in the top? So we know it's division, we know it's going to be a fraction of some sort. So what's in the numerator?
X9.
Yeah, x9 and that stuff, x squared plus 1, right? That's in the numerator. So it's all addition on those, so that's going to be all of those multiplied together. So we'll write it in a logical way. In a different. Yes, if there's addition and subtraction in the same problem, that's absolutely correct. That the addition stuff will be the stuff that's in the numerator. Think about positive exponents land up top, negative exponents go to the bottom. That's exactly right. So log base 5. Good. That's the logical way to write that. Divided by. What? All right, y and x minus 3. Doesn't matter what order you write that. I'm going to write the y in front. And then x minus 3, so it looks like distributive property. It doesn't really matter. Both of those are multiplied together in the bottom. Because think about it. This could be written like that. It's not, but it could have been written in that form. So that's why they're multiplied together in the bottom. Okay. Believe it or not, last example of the day. Not much longer. They don't get too crazy with these. Very good. That's absolutely correct.
There's going to be a cube root.
Is there? No.
I was kidding. That's going to be like to the third power.
What to the third power?
X.
Okay, where's that at? Like that. What's on the top? That's it. And we're not working to simplify anything here as far as algebraically canceling. We see x and x cubed could cancel each other out. That'll come in next section when we start actually, solving that stuff could happen. So it really is just condensing or expanding for this particular section that we're looking at. Make sure I've got what I wanted to get out of this. Get the right problems. All right, so problems you want to look at on page 456, 13 through.
Mr. Iswell,
Yes, ma'am.
could you post your attendance, please, sir?
I thought I did.
No, sir. Try it again for me.
Oh, I guess I didn't. Okay. All right. 3 through 28, and then we'll skip 13 through 28, sorry. And then we're skipping 29 through 36 and going to 37 through 70. Or 77, sorry. And the odds, obviously, on all those. You can do the even ones if you want to. Basically, what you saw in examples is what you're doing there. 37 through 56 is going to be expanding, and then 57 through 77, or 57 through 70 is condensing, and then there's a little work to do with the calculator there on 71 through that. So we'll see if you can figure that out. It's not something I'm quizzing today on out of this section, but I just want to put it in there. Figure it out. All right.